All right, so this is propagated error. I think that's what we call it. Yeah. I can't spell. Propagated error. And this is example, so they're going to call this number example, and then this is number 34 in the book. All right, so this says area, the measurement of the base and the altitude of a triangle are found to be 36 and 50 centimeters respectively. So I have a triangle where the base is 36 and the altitude, right, is 50 centimeters respectively. Possible error in each measurement is 0.25. So error is 0.25 centimeters. Use the differential to approximate the possible propagated error in computing the area of a triangle. So we want to find the error in the area of the triangle. Approximate the percent of error. Okay. All right, so first of all, we need to find the area, which is base times height, right? Okay. And, okay. And we got the base being 36 centimeters, and the error being delta B, which is 0.25. Okay. And the height of this being 50 centimeters, and delta H, which is there, is also 0.25. Okay. Questions so far? Okay. Well, technically, this is my dB, and this is my dH, right? So this is my differential dB, this is my differential dH, okay? So what we're looking for is the error will be my dA. dA will be my error. That's what we're looking for, okay? Because in this case, the error in the measurement was this, so now we're looking for this. So we got to look for our differential dA. So how do I find differential of dA? Take the derivative, right? We're going to take the derivative. So now remember, this is a two separate variables, so we're going to use a product rule, right? This being your U, this is being my V. So dA would equal, well, derivative or the differential of B, right? U prime would be dB. So dB times V, which is H, plus U V prime, which is B times DH. Does that make sense? Yes or no? Okay. All right. So now, so if I rewrite this, let's make it pretty. H dB plus B dH. So we have all the components to find dA, right? Don't we? Right? So dA is, the height is 50, and the dB, the error, is 0.25 plus B, which is 36, times DH, which is 0.25. Which then, when you punch in your calculator, what is it? Total?
Yes.
So I'm going to say 12.2, 12.5. I'm going to do it step by step here. 36 times 0.25 is 9. So this will be, what is it? 21.5. So that will be my error. That's what this is saying. That will be my DA.
Would it be centimeters squared?
Huh?
Would it be centimeters squared?
Yes, this will be centimeters squared. Centimeters squared. Because this was centimeters, this was centimeters, this was centimeters, this was centimeters. So centimeters times centimeters gives you centimeters squared. And that will be the propagated error caused by this error in the dimension. Okay, does that make sense?
So it's saying that's
How far off this is. So let's check. Look at this. Ready? So if I had an area, right, of this triangle, which is 36 by 50, right? 36 by 50. And when I multiply 36 times 50, the actual area of this triangle is 1,800 centimeters squared, right? Well, let's make this, let's add those to it. So if I did the second one, area would be 36.25 times 50.25, right? So if I did 36.25 times 50.25, this will be 1821.5625. That's the area, right? If I was off by that much. So the difference between these two, right? It would be, so change in A would be then 1821.5625 minus 1800, right? Where the difference is 21.5625 centimeters squared, right? So using the differential, dA, see, pretty fairly close estimate, isn't it? That's how you estimate the error, by taking the differential. Okay? So from the actual to the estimate, this right here, right? It's off by 0.0625 centimeters squared. Okay? But that's how you do propagated error. It's not too difficult, is it? No? So let's try. Oh, so then what they're saying is approximate the percent of error by computing the area of the triangle. So which technically we did. Here is this, right? That, oh, actually, this is the area of the triangle. And, or, should we do this? Comparing the area of the triangle. Or let's do that. So it would be 21.5 divided by 1,800. So 21.5 divided by 1,800. The error would be 0.0119. So the percent of error will be about 1% error. 1% error. Okay? Any questions? Does it seem too complicated or no? No? Yeah. Okay? Any questions about this? Let's try another one. You ready? Okay. There we go. Oh, I think they do use plus or minus because you could be off either side, right? Positive or negative when the error is that much, right? So I would recommend using plus or minus. So here's number 36. This is the volume and the surface area. Radius of a spherical balloon. So here's my sphere. The radius, right? Is 8 inches. So the radius is 8 inches. With a possible error, so my dr, or delta r, is, I'm going to say plus or minus 0.02 inches. So that's my error. Use the differential to approximate the possible propagated error in computing the volume of the sphere. So, what would be the volume of a sphere? You guys know the formula? 4/3 pi r cubed. So now we're going to look for dV, right? So dV is the derivative of this times dr, right? So bring down the 3, so I get 4 pi r squared times dr differential. So now we just plug it in. So dV, which is the error, propagated error for volume, is 4 pi, this is 8 squared, right, times plus or minus 0.02. So I'm going to be off by, what is that, 4 times that is, so I'm going to leave it in terms of pi, 5.12 pi. And that's my dV. Okay? And then this was A. So now let's do the surface area. Using the differential to approximate the possible propagated error for computing the surface area of a sphere. Well, how do you find the surface area of a sphere? You guys remember? 4 pi r squared. Thank you. 4 pi r squared. So you did the same again. dSA, right? Derivative of, a differential of surface area is 8 pi r dr, right? Which is equal to 8 pi, and the radius is 8, times the differential dr, which is plus or minus 0.02, right? So then 64 times 0.02 is 0.128. So plus or minus 1.28, sorry, pi. So this was a inches cubed, right? And this is inches squared. Am I correct? In units? Okay. Oh, kind of, yeah.
I mean, I don't know if that's on
Yeah.
purpose, but
Yeah, it does seem like it, right? Yeah. If the volume is 4 pi r cubed, then surface area, if you take the derivative of this, it gives you the, yeah. It does, doesn't it? Yeah. But any questions with this? So how would I do the error? What would be the error? Anybody? For this one. What would I do? Find the volume, right, which is 4/3 pi 8 cubed, whatever that is, right? And then we take this divided by, so, well, let's do this. We're taking this, dividing by this, right? Isn't that what we're doing, right? And this, sorry. So the error would be then 4 pi r squared dr divided by 4/3 pi r cubed, right? So then pi's would cancel out, r squares would cancel out, right? 4's would cancel out, 3 will flip to the top. So this will be 3 over r dr will be my error. This is the error, right? So this will be 3 divided by 8 times the plus or minus 0.02. That would be my error. If I were just to do that. So 3 divided by 8 times 0.02. So I'm off by 0.0075, and so this will be 0.75% of error would be it. Which is not that big of an error, right? But still. And because our measurements are really pretty precise, that's probably why. Okay. Any questions? Is propagated error difficult? So if you know your differentials, that's all you're doing is plugging it in. And that will be the propagated error, how it affects. Okay?
For finding the percent error, it's the derivative, or the differential.
Divided by the original.
And then times by 100 when you get
Yes, make it a percentage. Yeah. Okay? Was there something else I was supposed to cover today? I think that was it, right? Okay. Hi guys. Everybody say hi guys.
Hi.
Hi.